Good morning, ninth grade. I hope you had a good weekend. I hope you're ready for another day of school and another unit in math. Ninth grade, we are 9.1. We are unit 9. That means we only have 2 more, and we're done. So 9.1. We're working with quadratic equations again. We're extracting the square root out of both sides. You've done this before, but there's one little key that I want you to really notice, and I'll put them on the board. It's positive and negative. In extracting a square root, your answer can be positive or negative. Okay? So if I had, just use for an example, if I had the number of 81, and the square root, I could have 9, and it could be a positive or a negative. You got that? And the square root of 89 can be positive or negative. And so instead of writing 9 positive and 9 negative, we just put the positive and negative sign in front, and that tells you that it can be for either one. Now, why am I telling you this? Because this is extremely important. So number 1. Problem 1 of 9.1, if you are on page 417, what you do on one side, you need to do on the other side. X squared and 100, so I just put the square root right on top of that one. X squared, isolated the x, so I got x here. You know, square root of 100 is 10, so I put 10, and look what I did. You see that positive and negative? That positive and negative is part of my answer. If you put just x equals 10, it's not correct. Okay, let's work to, I'll skip 2, go to 3. In number 3, you have x squared negative 49 equals 0. So you're working with the equation, get this 0, get the 49 over here on this side, okay? Eliminate the 0. Move the 49 on this side of the equal mark, so your problem should look like this. If you move the 49 over, put the 0 over here, there's no need writing the 0 down. He's not of value. So you see, when you move the 49, you brought him to a positive. When you brought him to the other side of the equal, you made him a positive. So be sure to do that. When you switch them back and forth, be sure to change the sign from negative to positive. Now you have a problem just like we did up here. X squared plus 49, square the x, leaves you with x. Square 49, leaves you with 7. Again, I put the positive negative because it could be x negative and it could be x positive. Let's do 4, yeah. You have 9x squared equals 49. And this 49 is not difficult. You can quickly run him down. X7. Now this one here is a little bit different because you have a number in front. So you got 9x, so the square of 9 is 3. If you square here, I put the square sign, or the radicand sign. And so you come down to the 3. Okay? You have 3x. Matter of fact, I should probably do it this way. Okay, you can get down to this point real quickly. I mean, you've done this, it's not hard. You square this one, you square this one, and you may be tempted to stop right here. And that you can't, okay? You have to take it further. You have to get x by itself. Okay, so now, on this problem, that marker wore out. On this problem, to get the x, to isolate the x, you'll have to put a 3 here, and now you have the x. And so you come over here, you'll need to put the 3 over here because what's done on one side must be done on the other side. What do you got here? I mean, you can't divide 3 into 7. Well, you just have a fraction. No problem. It's even an improper one if you send it that way, but in algebra, it does not matter. And did you forget to put the plus and negative? X could equal negative 7, 3, or it could equal positive 7, 3. That's your answer for number 4. Let me scoot you over for 5. see. Okay, for answer 5, or number 5, you start out with x plus 1 in parentheses squared equals 25. Now that's not real hard. You can square that x plus 1. That means there's just 2 of them. So you square, I didn't do it. I didn't put the radicand sign over the top. I just know that there's 2 of these, so I square it. There's 1 of these, and the 5 is negative and positive 5. Okay, here again, it's like that other problem in 4. You can't stop. You have to isolate the x totally by itself. Now you're in trouble because you have a negative 5 and a positive 5. And so when you add, when you take the 1 over here to isolate the x, you subtract 1. If you subtract 1 from positive 5, you get a different answer than if you subtract 1 from negative 5. Okay? So now you've got to work out 2 separate problems to isolate the x. And I made 2 arrows here. So let's say we bring the negative 5 right here. Are you with me? Here's the negative 5, and I split this 5. Here's the positive 5. Okay? And now I have x plus 1. X plus 1 equals negative 5. So I just worked that one out. Subtract 1 here, subtract 1, move the negative 1 over here. I have x equals negative 6. 1 and 5 equal negative 6. You can do that. Now with the positive 5, I did the same problem. I have x plus 1 plus 5. Now I subtract the 1 to isolate the x. I subtract the 1 from positive 5, and I have 4. Can you see that? It looks like the lights are glaring there. This one is positive 4, and this one is negative 6. So x can actually, in this problem, mean 2 different answers. It can either mean negative 6 or positive 4. And there will be a number of those that will have that. You'll just have to write them separately. In reality, though, before you get too confused, this here, when you're writing positive, negative 7, oh, I went too far here, you can't see that. Right here, when you write positive and negative 7, 3, you actually have 2 different numbers, okay? So don't think that one at a time you have 2 answers, and the next time you just have 1 answer. No, that's not true. Even though you just write it down one time, when you put that positive negative sign in front, automatically tells me that there's two answers. Yeah, enjoy your lesson.